Okay, so this is a continuation of lecture 1.4, and we were talking about piecewise functions. So, yeah, as you guys saw, piecewise function has, contains or is composed of at least two different functions, right? So we had one function, f of x equals 2x plus 3, and the condition is that function holds if x's are less than 0, and then the other function, negative half times x plus 3, and that function applies when x is greater or equal than 0. Okay, and then we were evaluating that function for three different x's, and then we saw that if you plug in this, then we need to use the red function, right, because negative 2 is less than 0, and then for 0 this one, and for 2 also this one. So the next thing we'll do, we'll graph that. We'll graph that function. And I'll show you the way I do it. Maybe in your textbook is done some other way. I'm not sure. But I tend to just graph both of them, right? So this is y equals 2x plus 3. So let's try it. And I'm just going to sketch it. You know, we're more concerned about concepts rather than how perfect those graphs are. But anyway, so see that the first function is let's have units like this. Actually, let's make it what is it? Red. Okay, so I'm gonna make it red, and I'm actually going to make it kind of graph it light. So I don't worry about this condition, right, that x is less than 0. So I'm just graphing y equals 2x plus 3. Okay, so I see that 3 is the y-intercept, right? So if I plug in 0 for x, I will get y equals 3. So that's my y-intercept. And then I see that the slope is 2, right? So for 1 unit to the right, I go 2 units up. Okay, so that's going to be a point, that's going to be a point, and that's going to be a point. Okay, so I'm lightly graphing that with a dashed line, graphing that 2x plus 3. Okay, so that's the first function, and I still don't worry about that condition x is less than 0. Okay, and now I'll graph the other one. So the other one has a negative slope, negative half x plus 3. So it has the same y-intercept, 3. But this time, right, it's for 2 units to the right, I go 1 down. Okay, so I'll have a point right there, and then point there, and then there. Okay, so that's my second line. That's going to be the green one. And again, I'll just graph it lightly. Okay, straight line. It's not super straight on my picture, but it's supposed to be straight. So now I need to think about these conditions. Okay, so the first function is for x's that are less than 0. Okay, so x is less than 0. So those x's, right? So this is my red function, red graph. And x less than 0. So I need to exclude this. Okay, so you see I put an open circle for x equals 0. Okay, so that 0 doesn't belong to the first function. So this one is y equals 2x plus 3. Okay, so now I'll graph the second one. Second one is green. And 0 actually belongs to that function. So I will fill that 0 with green. Okay, and then I'll just graph that. Again, right? It's supposed to be just straight. So this one is y equals negative half x plus 3. Okay, so that's the graph of this piecewise function. Okay, so it looks like this. You see those two pieces, right? The red one for the first function and the green one for the second function. Okay, so that's graphing. There are other things that we can do with those functions that are interesting. Interesting means usually means difficult, right? So let's see. So the example 2. So this time we'll have f of x, and we'll have a function composed of 3 functions. So the first one goes like this, negative 2x plus 1. And if x is between or greater or equal than negative 3, less than 1. So 1 doesn't belong to this function, because 1 belongs to the second function. Okay, so the function gets a value of 2 if x equals 1. Well, that's the rule, right? But it's just a constant function. And here we have a parabola for x's bigger than 1. Okay, so now what we need to do is a couple things. Domain, and we'll do them before we graph, because we need to find those intercepts algebraically, and domain we can just deduce from what's given here. Okay, so then we'll graph it, then we'll do, the last thing we'll do is range. I forgot to focus it in a certain spot. Okay, so let's start with domain. And domain, right, is the axis for which the function is defined. So let's see here. So the function is defined for sure for x is bigger than 1, for x is equal to 1 as well, and for x is between negative 3 and 1. Okay, so the function starts at, so if I had a number line, right, the function starts here, negative 3, then we have some 0, 0 is not really a point of interest here, then I have 1, right, and then the function keeps going to the right. So you see that function starts at negative 3, and it's defined for negative 3, right, because I have that equal sign here. And then it goes towards 0, it goes through 1, right, so here I have an open circle for this, but then, right, it's covered by that second function, so it just keeps going to the right. So from negative 3 all the way to infinity. All the way to infinity. Okay, so that's the domain. So now let's look at the intercepts, because they're probably the most interesting. Because we have all those 3 functions, maybe they all have different intercepts. Let's see. So we kind of need to look at all the functions and figure out whether we'll have intercepts for all of those. Okay. So let's see. Let's start with the first function. Let's do y-intercept. So for y-intercept, x is equal to 0. Okay. So let's mark it. Let's use some color. So green for the first function. So let's say I'm doing the green one now. So f of x equals negative 2x plus 1. So first question is, well, can I even plug x equals 0 to the function? Is the 0 part of the first function? Well, it is, right? Because 0 is between negative 3 and 1. So I can do that. So I'll do f of 0. So I'll get negative 2 times 0 plus 1. My pen is dying. Let's use this one. So we have 1. So our intercept our y-intercept will be 0, 1. Okay, so we got it from the first function. For the second function, for this, how should we do this? Yeah, let's do all of it for, let's do just y-intercept for the first function. Well, you guys should know that the function can only have one y-intercept. But anyway, let's see what happens. So if I take x equals 0 and try to plug it into the second function, well, it doesn't really work, right? Because 0 is not part of that second function, right? It's not part of the domain of this second function. Because here, the only x I can plug in is 1. Okay, the same thing happens for the third function, right? I cannot plug in 0 in here because 0 doesn't belong there, right? Okay, so let's do it properly. So let's do the red one, and we'll say f of x equals 2 if x equals 1. So here no y-intercept. Okay. Let's do the last one. So this one, and f of x equals x squared if x is greater than 1. So no y-intercept. Okay, let's put a comment, because x equals 0, not part of domain of this, right? Or not in domain. Okay, so let's think about x-intercepts now, because we can have more than one, right? So maybe there'll be more than one. So for x-intercept, the y needs to be 0. Okay. So let's try the green one. See if there's an intercept in the green function. So y needs to be 0. My function is f of x equals 2x, negative 2x, right? Negative 2x plus 1. So this is y. Then I write 0 equals negative 2x plus 1. So now we just solve it. Okay, so we move the things around. So this one, or maybe this negative 2x to this side, so I get 2x equals 1. So x equals half. Okay, so that was the green function. Let's look at the red function. So here f of x is just 2, right? So I get, if I plug in that 0, I get 0 equals 2. So no solution or contradiction. So the conclusion will be no x-intercepts. Okay, arising from this part of my function. And the last one was f of x equals x squared. So I plug in, I need to plug in 0 here. So I get x equals 0. But then the problem is 0 is not in the domain of that function, right? So no x-intercepts, because x equals 0, not in domain. Okay, so x equals 0, that's our intercept, but technically x squared does have that intercept. But here, this function is defined only for x is bigger than 1. So we need to throw away this something that normally would be our intercept, but in this case is not, because x is not in the domain of this function. Alright, so let's graph it, and maybe this way you'll see what's going on. Yeah, so when you guys are doing those intercepts, you're going to have to go through the same process, right, of trying to figure out what those intercepts are. Anyway, so let's piece this function together, this piecewise function. Let me think. So what should be the... Can we have this as 1 to make it bigger and clearer what's happening here, right in the middle? Okay, so the first function is negative 2x plus 1. So it crosses the, and again I'm going to do everything very lightly. So it crosses the graph, or I mean the y-axis right there. And then it's a negative slope, so y equals, let's use those colors. What colors did I use here? So green for the first one. Okay, so y equals negative 2x plus 1. So I have 1 as my y-intercept, and then, and again it's this, I go, slope is 2 or negative 2, right? So for 1 unit to the left, I go 2 units up. Alright, so let's actually make it not green, but first dashed. Okay, so this is my graph, the first one. And what was the, so it went between, so that was supposed to be green. Let me actually graph it properly now. So between negative 3, so from here, okay, from here all the way to x equals 1. But then I get an open circle here because 1 is not part of the function, right? So you guys see that this green dot, right, should be part of the graph. Okay, this see, I said open circle here, but it's not an open circle. This is just an intercept. This is 0, right? Not 1. X equals 0, and it does belong to the graph. Okay, so this is my y equals negative 2x plus 1. Okay, then the second function was just y equals 2 for x equals 1. So that was, what color was that? So that was red. So that will be right there. So it's just a point. Okay. And then the last one was a parabola, and that was blue. Parabola, that is, right, so for 1 you get 1, 0 you get 0, and then for 2 you get 4, so that will be here. Let me just graph it lightly. Okay, so then it keeps going, right? For 1 you get 1, for 2, for negative 1 you get 1, for negative 2 you get 4, etc. Right? So it should be here. But that part doesn't matter, right? Because that function is defined only for x is bigger than 1. Okay, so we start right there, make an open circle, and the function keeps going up and to the right. Okay, so this one is y equals x squared. And this one is y equals 2, but only for x equals 1, right? So that's the function. So only the colored parts, right, matter. Okay. What else here on this graph? Yeah, so let's look at those intercepts that we found, right? So we found y-intercept 0, 1, and we found x-intercept half 0, right? So that's this one, and this is right here. Okay, so it's 21 minutes. Let's stop here.